Today's Friday, April 16th. Don't forget, every day you need to be practicing your benchmark, fractions, decimals, and percents. Today we're reviewing inequalities. Basically, we've been really focusing on equations for this whole week. Equations means that one expression is exactly equal to another expression, and if there was a variable involved, there's only one answer to an equation. Inequalities are, as you can tell, not equations. In fact, the prefix "n" means not. So inequalities means not equal. There's more than one answer to an inequality. We've already studied this and we are reviewing these ideas, and we need to remember that we need to be able to use a number line in order to show the various possible answers to an inequality. And we also need to remember the various symbols to show inequalities as well. So if you look over here at this picture, if you have an equation, x is equal to -2, well then the only answer is -2. That's it. But if you have x is greater than or equal to -2, then -2 could be an answer, but then everything else that's greater than -2 is also a possible answer. Same thing for x as being less than or equal to -2. -2 is a possible answer, but so is anything else that's less than -2. If you don't have the equal to symbol, which is a line underneath the greater than or less than symbol, then 2, like x is greater than -2, -2 is not a possible answer, but anything greater than -2 is. So those are called boundary points. That's an open boundary point, and that is not equal, but that's where it begins. And x is less than -2. -2 is the boundary point. X cannot be equal to -2, but anything less than -2 can be a possible answer. So inequalities have infinite numbers of answers. All right, less than symbol, greater than symbol, less than or equal to, greater than or equal to are all things we need to remember how to recognize. Let's go ahead and look at the textbook. Here's another chart that shows what the various symbols mean. Today's lesson, we're really focusing on whether certain values can be true given an inequality sentence. So this says that f plus 2 is less than 9. Can 6 be a possible answer? And so you can see here, 6 plus 2 is 8. 8 is less than 9. So yeah, 6 is a possible answer. Could 7 be a possible answer? 7 plus 2, if we replace the letter f, with 7. 7 plus 2 is 9. 9 is not less than 9, so that's not a possible answer. 8 plus 2 is 10. So if you replace the letter f with 8, that can't be an answer because 10 is not less than 9. So those are those kinds of questions we're going to be practicing how to do here in just a little bit. Is a given value a solution to an inequality? Same thing. We have a variable here. The sentence, the inequality sentence is x plus 3 is greater than 9. If we replace x with 4, 4 plus 3 is 7. 7 is not greater than 9. You can see we've drawn a line to show that it's not a possible answer. Okay, so we're going to do a few of these practice problems together. Okay, so if we know that inequalities have an infinite number of answers, but not everything is a possible solution, we're going to practice figuring out if given values are actually possible solutions. So this says that 9 plus a is going to be less than 17. 7, 8, and 9. Which one of these, or it could be more than one, would be a possible solution? So replace the 7 with the letter A and see if that would be true. Replace the 8 with the letter A, replace the 9 with the letter A. 9 plus something is less than 17. Which one of these numbers would make that true? Answer that for me now. Okay, so what is 9 plus 7? Very good. That is 16. Is 16 less than 17? Yes or no? So 7 is a possible answer. What is 9 plus 8? That's right, 17. Is 17 less than 17? No. So 8 is not an answer. What about 9 plus 9? What is that? 18. Is 18 less than 17? No. So the only possible solution in of these three numbers is the number 7. But noticing the pattern, 8 and 9 were not possible solutions. If 7 is a possible solution, is everything less than 7 a possible solution, or is everything greater than 7 a possible solution? Very good. 7 and anything less than 7 is a possible solution to this inequality. Okay, let's use what we know about inequalities to solve this word problem. The classmates below have a cell phone plan that allows for 200 text messages per month. Use the inequality A plus B is greater than 200, where A is the number of texts from week 1, B is the number of texts from week 2, to determine who is already over the monthly budget of 200 texts. So the key word here is going to be over. So I'm going to circle that. So A plus B is greater than 200 is the inequality from the word problem here. Okay, so what is 25 plus 50? Answer that, please. Very good. That answer is 75. We should be able to do that in our heads because of the quarters. What is 150 plus 10? Answer that, please. Very good. That answer is 160. That should also be something you could do in your head, 50 plus 10. What is 125 plus 110? Answer that, please. 100 plus 100 is 200. 25 plus 10 is 35. So that should be 235. And then we have 100 plus 100. What is that going to be? 200. Very good. Okay, so of all four of these, which person qualifies for being greater than 200? Very good. The answer is Sierra. Sierra has already exceeded her plan because 235 is definitely greater than 200. All right, Hannah's backpack can hold no more than 30 pounds. She has a laptop that weighs 7 pounds and books that weigh 5 pounds each. What's the maximum number of books that Hannah can carry in her backpack? Okay, so we know that there is a limit to what Hannah can hold in her backpack. What is that limit? Very good. 30 pounds. So everything in her backpack has to be less than 30 pounds. What is something we know that she needs to carry in her backpack? Exactly, her laptop. So that's 7 pounds. And then she can carry some books. What information do we know about the books that's important? 5 pounds, very good. So how many books can she carry and still be less than 30 pounds? So I'm going to go ahead and do a bar diagram. And if I have 30 as the maximum, and then we have 7, so we have 5, 5. So go ahead and figure out, guess and check if you'd like, how many books would be possible for us to carry. Go ahead and work that out. Okay, now there's more than one solution here, but we know that if we take away that backpack, we know that we still have 23 pounds we can put into, if we take away the laptop, sorry, we still have 23 pounds we can put in the backpack. I know that 6 times 5 is 30. But if we have to carry the laptop, then we can't carry 6 books. So if I have 23 pounds left to um, use here, 4 times 5 is what number? Exactly right. 4 times 5 is 20. So I could carry um, 1 book, 2 books, 3 books, but the maximum number of books, if I want to also carry my backpack, is going to be 4 books. So if I have my laptop in the backpack, then the maximum number of books I can carry is 4. All right. So what we need to do is think about what are some important things that we've learned today, and I want you to answer that thoughtfully. Go back and look through the notes about inequalities that we reviewed. Open up your textbook to page 636 and look through the examples that we reviewed together. And what is something important to remember about inequalities that you'll need to use in 7th grade and on a SIR test? Answer that for me now, please. Thank you for your thoughtful answer. Please make sure you come to class. We do more practice together. Also, make sure that you're coming to Math Help if you have any questions, or if you're behind on assignments and need help with something. It's really up to you to reach out for help, and I will help you with anything that you need to go over again. Thank you.